to Dr. Kenji. First of all, let me introduce myself. I'm Sibing, representing AP Bionet. On behalf of AP Bionet, I would like to thank you for giving support to our event InCoB2018 in New Delhi.
Thank you for the invitation.
And also, we would like to thank you for giving us your precious time for this interview.
My pleasure.
So before we start on with some hardcore interview questions, why not we start off with something more casual? Probably the participants out there, the scientists, researchers out there would like to know more about Dr. Kenji. Can you briefly tell us about yourself?
Okay, as you can tell, I'm Japanese.
Yeah.
I studied physics first. Then I got interested in biology. But I wasn't sure I can make any contributions. So then I found a professor who's also a physicist, but originally, but works on proteins. So I decided to do a PhD under his supervision. And that's how I started working on proteins using computational methods.
Okay.
But at that time, I still treated proteins as physical objects rather than biological objects. But eventually, I thought I could do more in biology. So after my PhD, I decided to go abroad. I decided to go to the United Kingdom to do a postdoc in a structural biology lab. So many of the other members in the lab do X-ray crystallography to determine new protein structures. So in that environment, I continued to do work using computational techniques. Then I tried to develop new software and for predicting protein structure and function. That's how I guess became a bioinformatician.
Okay. I guess probably Dr. Kenji can tell us more on what is your current research, the recent research.
Okay.
Yeah.
So our research now focusing on drug discovery and development. So it's a very hard task, as you may know. Developing new drugs is a very long and costly process. And there are a number of problems. And we want to address some of these, not all of them, of course, using computational tools. So it's not just protein structure or docking. There are a number of other, or perhaps more important issues. So we want to look at a wide range of data sources, such as clinical data, genomic data, and also some other information from approved drugs, chemicals, and how chemicals interact with proteins. So all sorts of things we want to integrate. Then try to tackle some of the bottlenecks in developing new drugs.
Can you tell us what approach that you use in sourcing out useful information on all this data?
Yeah, so that's the challenge.
Yeah.
There's lots of data available, but they are not in a computer-friendly format in many cases. So we can use different techniques. We can apply computational techniques such as text mining, natural language processing, to extract relevant information automatically. But in many cases, we have to do manual curation. We have to look at the literature. We have to read the papers, and then we have to do manually extract information. And then ultimately, we want to integrate different data sources. So we use different techniques in data integration, database development, to create a data set that is structured and computer-friendly. So I believe this is really
Ultimate
a basis
aim.
for all sorts of other applications like machine learning.
Okay. Can you help us to summarize the key point or take-home message of your talk in your session?
or in my session.
Yes.
I've just mentioned that the data integration is
a brief one.
Yes.
A brief one.
Yes.
Yeah.
So I think I need to reiterate that data integration is key to everything.
Okay.
And also, perhaps compared to some other speakers who focused on, say, genomes, proteins, or diseases, I hope that I can mention that there are other interesting data sources, such as those used for drug approval. Companies will submit a package with all sorts of information about new drugs. And there are also some other documents publicly available about existing drugs. And then, of course, we can get various sorts of information from papers. And so all sorts of what we call real world data would be interesting. And I want to tackle, I want to look at these.
Okay, so let's move on to, can you give us some comments on the importance of bioinformatics to the research question that you are currently addressing?
Yes, so again, making drugs is as complicated.
Yes, yeah,
task.
definitely.
And so you have to deal with a variety of data. And using computers is essential, really.
Yeah.
And so it's quite natural
Yes.
to assume that computational methods, bioinformatics, and computational biology are absolutely essential for tackling complicated biological questions.
Okay, good. Okay. I guess now probably we move to future. We talk about future.
Yes.
So how do you see the rapid change in bioinformatics affecting science in general, specifically your area in probably drug discovery?
Yes. I think so. Well,
Data science.
Yes,
again.
data science. Yeah, drug discovery. But we need more data, actually.
Yes, true.
So we still need to create new data using experimental methods. But perhaps computational methods, bioinformatics, can guide new experiments. And maybe we can design robots or other automated techniques to generate new data and then use these for training algorithms and develop new computational tools. So this would be a good cycle for the future.
Yeah, I agree on that. Yeah. So as AP Bionet Secretariat, as you know, AP Bionet, the missions of AP Bionet is to promote bioinformatics and outreach to as many in scientific community, right? So my last question here is, what would be your advice to aspiring scientists or bioinformatician out there?
Okay, so I feel I've been quite lucky working or doing science for such a long time. I hope people can find what they feel they are enjoying.
Yeah.
So I think that's the most important thing.
Those are the things that motivate you.
Find something that you find interesting and you want to do really for a long time. So I hope that's the most important thing I would say.
True, I agree on that. Yeah, because the things that you like, you will have the motivation automatically.
Exactly, yes.
Yeah. Well, I guess that's all. Those are the things that we want to know about Dr. Kenji. And thank you so much for having. It's our pleasure to have you in our event.
Well, thank you for the opportunity.
Thank you.